All right, stats, here we are for your Tuesday, the 26th video. We're on page 3 in your packet. By page 3, well, I mean, there should be a 3 at the bottom, and we are looking at this one. We're not going to talk about independence yet. Let's say that. We're going to talk about number 8 right away, but first, let's get to our sponsors, Cliff Bar. All right, speaking of Cliff Bar and climbing mountains and doing outdoor stuff, Rocky Mountain National Park. And one of Dr. Seuss's famous, there's a Wocket in my pocket. Folks, do you ever feel like there's a wasket in your basket? Yep, me too. So, number 8 says, a signal is transmitted over a noisy channel. It is known that the signal will be correctly received with probability 0.625 of every 8 signals, 5 are going to be received correctly. If 4 copies of the signals are independently sent over this channel, what's the probability that at least one of them gets through? We need one of them to get through. So the probability that the signal is transmitted correctly is 0.625. So 4 copies are going to be sent independently. So X is a correctly transmitted signal, and we want the probability that X is greater than or equal to 1, which means we want 1 minus the probability X is 0. Folks, you need to get used to just writing everything down that you know, especially using mathematical symbols, okay? That is what we need to know for any stats course going forward. So I do 0.375, the probability that it does not go through, raise it to the 4th power, that is 0.20. It's 0.20, that's how that's going around. So a 98% chance. If you send 4, one's going to go through. 0.98. All right, so what does number 9 say? This is really expected value question. So 9 says the voters in a large city are 52% whites, 33% black, and 15% Hispanic. The mayoral candidate anticipates attracting 40% of the white vote, 60% of the black vote, and 40% of the Hispanic vote. What percent of the overall vote does the candidate expect to get? This is expected value. The expected vote is 0.52 times 0.40, this is the white vote, plus 0.33 times 0.60, that's the black vote, plus 0.15 times 0.40, just as it's written, that is the Hispanic vote. And let's multiply these together. 0.52 times 0.40, that is 0.208. This next one has got to be 0.198, right? That is it. Plus, this has got to be 060. Yes, 15 times 40, you know it. Add those 2 or 3 together. Try to adjust here. 0.466. What percent? 46.6%. All right, then it says here, look at page 8 in your note packet again. We either have this, I mean, you don't necessarily need it printed. If you have it printed, great. But you need to at least have it on your Chromebook like I do. Whoa. So page 8, conditional probability. Let's go. You know this right here. The probability of A is greater than 0. The conditional probability of B given A. So what's the probability that B happens given A has to happen? This is the formula, and it's going to be one that you're going to have to know. Now, I go alphabetically, so I say the following. What is the probability of A given B? So it's all about the denominator. What's the denominator? The denominator is that B happens, so it's the probability of B. And then, why is it the intersection up top? Well, if I'm asking what's the probability of A happening given that B happens, I want to know what's the probability of A, but B also has to happen. So A and B are both happening. That is the intersection. Okay, so that is one that they don't give on a formula sheet. You just have to have that down, okay? And it's like, have we done the intersection? Like the intersection one, probability, or the union, probability of A union B is equal to probability of A plus probability of B minus their intersection. It's also one that we have to have down. They don't typically give that one. All right, look at page 9, the next page. Awesome. This is definitely not a view. What's happening there. Look at page 9, computer games. 12.8 computer games. Okay, so a little outdated again. What, 12 years difference here. Here's the distribution of computer games sold by the type of game, a strategy all the way down to other. What is the conditional probability that the computer game is a role-playing game given that it's not strategy? Given that it's not strategy. So I always want a probability statement. So probability role-playing given not strategy. All right, so what has to be the denominator? Not strategy. So if strategy is 354, 1 minus 0.354 is going to be the denominator. The denominator is not strategy. So what's the probability it's a role-playing game? Well, what is probability it's a role-playing game? Given that it's not a strategy, so this is going to increase the chances of having a role-playing game because you're eliminating the strategy. So divide them together and you get a 215.215. All right, so about what's the denominator first? This is a good one. This is from 2004, so a little outdated. We should probably update this, huh? Civilian labor force in the United States in 2004. Non-institutionalized civilians, at least 25 years old. It's given in the table below. Figures in thousands. Okay, so this is actually a million. So it's 125 million. Anyway, a few totals off by rounding. Okay, given that, so here's what we're going to do. So there's a table. You have the table. I'm going to write it over here. All right, so given that a person is unemployed, so the given is always listed second. What's the probability that they have less than a high school? So probability less than high school given unemployed. So the given is the denominator. So given that they're unemployed, how many are unemployed? 5.5 million. So the 5, this is the denominator, again in thousands. All right, that given part goes seconds. And the intersection of having less than a high school and unemployed goes up top, and that is this number. All right, that's the intersection of unemployment and less than high school, that little cell. So let's divide, always round to 3 decimals. 193, so given that a person is unemployed, the probability that they have less than the high school degree is almost 20%. Given that a person is employed, what's the probability they have at least an associate's? Ooh, this is interesting, at least an associate's. So probability of at least, we're going to say greater than, we're not going to abbreviate associates, greater than or equal to an associate's, given that they're employed. Again, always concentrates on the denominator first. Given that they are employed, they have to be employed. How many are employed? This many. Again, in thousands. So given that they have at least an associate's, well, associate's degree and employed is this. And then you got to add it to bachelor's and higher, because at least associates means you start at an associate's and you get everything above it. All right, so 11, 693 plus 39, 293. Oh, I did. Yeah, 39, 293. Okay, is 5986, which is 462. So of people that are employed, 42.6% of them have at least an associate's degree. That's what it's saying. So what's the unemployment rates for those individuals who have a high school diploma or less? Goodness. What's the unemployment rate? So we're just going to say rate equals, unemployment rate is a percentage for those that have a high school diploma or less. So that is high school grad, no college, plus less than high school. So the denominator is all the people eligible to work of those two. So this is high school diploma and less, and this is not a high school degree. All right, And we care about the unemployment rate. So this is how many are unemployed in the high school graduates. And this is how many are unemployed in the non-high school graduates. And what is this, 2952? Yep. And up top you have the 37,834 plus 12,470. All right. And you do 2952 divided by 50, 304. And here is what you get. And that is a 5.8% unemployment rate. All right. What is the unemployment rates for those individuals who have an associate's degree or higher? So we already know how many have an associate's. No, we don't, not fully. So we got to add up just the total amount of people eligible to work with an associate's degree or higher. So again, the rate, the unemployment rate for people with an associate's or higher. So first off, all the people eligible to work with an associate's degree is this number. And the people that are unemployed with an associate's degree is this number. Plus all the people with a bachelor's degree or higher that are eligible to work, this number. And all the people unemployed with a bachelor's degree or higher, this number. All right, let's add them up. 1545 over 12,141 plus 40,390. 52,531. Their unemployment rate's going to be just under 3%, right? 029, which is 2.9%. So it's about half of the high school diploma or less. So what percent of eligible workers had less than a bachelor's degree in 2004? So eligible workers is that big total. I'm just going to say percentage. I'm going to save time here. Is that entire total at 125 million. So it had less than a bachelor's degree. Well, we take the entire total and we minus everyone that has a bachelor's degree or higher. All right. 125, 133 minus 40, 390. 84, 743 over 125, 133. 677. What percent? 67.7%. All right, and then finally here, what percent of eligible workers had less than a high school diploma in 2004? Had less than, that's how many eligible workers we had, and the total that had less than is 12,470. 12,470 divided by 125, 133. That is going to round to that 0096 would round to this 10% of eligible workers. All right, look at that, page 10. Nice one. Let's see that question a bunch. Okay, good page for us. What I want us to do then is to go to page 16. We are talking about another Venn diagram here. People that have taken Calc 1, 2, and are, imagine, math majors. If you want to major in math, you're going to take the Calc series 1, 2, and 3. So if you ask an undergraduate, freshman or sophomore, you know, if they're really, really sharp and they come in with Calc 2 and you interview them as a, you know, sophomore, you know, maybe and in the spring, maybe technically in the past year they haven't taken it, or maybe they're saying they're a math major and they haven't gotten past pre-calculus. So it's like, I don't know, man, if you are majoring in this. So you can also, instead of P, you can say the number of, because we don't have probabilities here, we have the number of. All right, so this is also true. The number of A union B is equal to the number of A plus the number of B minus the intersection. That's also true. Substitute in for P. So 153 had had taken Calc 1, 187 had taken Calc 2, and 134, so they've taken both, which is probably the proper response. All right, so there's 153 that had taken Calc 1, so I do 153 minus 134. 19 had only taken Calc 1 the past year. And I do 187 minus 134. 53 had only taken Calc 2 in the past year. And how many were interviewed? 251. So I do 251 minus those 3 circles, because there are going to be some folks that haven't taken either. Either maybe we're just interviewing a freshman and they're only in pre-calculus. So that could be it. Or, I don't know, they came in like super advanced and they started in Calc 3. And we interviewed him as a sophomore. I wrote down the wrong thing. 19 plus 134 plus 53. That is 206. So 201 minus 206. 45 of them. 45 of them are in that outer part. What's the probability a student is taking only Calc 2? Probability only Calc 2. I said B was Calc 2. Okay, so 53. Round to, I'll have you round to 3 decimals on that one. Point, what, 21 something? It's probability of taking none. Probability of neither. 45 over 251. Let you do that one. Point what? 179. It's probability only Calc 1. Probability only Calc 1. 19 over 251. I'll let you do that. I'm going to go 0.075-ish. All right. Then, got page 17. So I made a little typo here on B, C, and D. But page 17, you got 3 big ones going with MIT, Massachusetts Institute of Technology. Right across the Charles River. It's right next to Harvard. Anyway, I got you one guy when we did the Boston Marathon 2017. Said hi to this guy outside. He's like, hey, I went to MIT and I'm running the Boston Marathon. You want to take a little tour? And took my dad and I on a little tour. And that was pretty cool. Vanderbilt University. I tutored a next door neighbor of my parents actually over a decade ago, and she's now at Vanderbilt Law School. All right, and Carnegie Mellon, one of my good buddies, was in my wedding. I went to Carnegie Mellon. That is a very prestigious school in Pittsburgh. Vandy here, as we'll abbreviate, is in Nashville. So the probability that you get into MIT is 0.39. Probability you get in Vandy is 0.43, and the probability you get in Carnegie Mellon is 0.4. Then you have the probability that you get into, both MIT and Vandy. This might be your first 3 bubbles here, 3 circles. Probability you get into MIT and Carnegie Mellon. Probability you get into Vandy and Carnegie Mellon, and probability you get into all 3. So the all 3. Now, the way I've designed this, you might do something a little bit different, but the way I've designed this is right here. So I'm going to put 04 in there. And then the only subtracting you're going to do is for A only, B only, and C only. Okay? So A and B, that number does go there. A and C, that number does go there. B and C, again, the way I've designed this one, goes there. All right, so probability that you get into only A is going to be 39 minus 12, 4, and 4. That's 28. Probability that you only get in MIT is 0.11. Probability that you only get into B is 43 minus 26.17. Probability you only get into C is 40 minus 26. That's 1/4. So just be very careful there. Now, if you add up all those numbers, because probably you don't get into any of them. What is this? 23, 40, 50, 62, 66, 80. Can check my math. Be real sad if I got that wrong. 40, 50, 62, 66, 80. Feeling good. 20% chance neither says. So I know it's a typo on mine because it goes to what? Instead of saying all those, because it says Harvard, Yale, Cornell. That's like a Common Core question. I give you all these. I'm like, oh, what's probability getting at Harvard? So no, call it MIT, Vandy, and Carnegie Mellon. So what's probability you only get into MIT? Probability MIT only. That's A, right? And then probability of Vandy only. That's B. And then probability Carnegie Mellon University only. It's 1-4. Okay. Oh, man. Trying to rest my foot there. What's the probability they get into at least 2 of the 3 schools? So at least 2 of the 3 means you add that, and that. Those 4 intersections. So probability at least 2 is 12 plus 04 plus 12 plus 10. 24 plus 14 is a 0.38 chance. 3 out of 8 chance you'll get at least 2. What's probability they get at least 1? Probability at least 1. You can add everything inside a circle, or you can do 1 minus what is outside. You got an 80% chance of getting into at least one of those very prestigious schools. All right, folks, we have got a nice long video here for you on a Tuesday because I've got as well these examples. Add these questions to your notes. So write this. So here's what we know. You got to be prepared to know this. Probability of A union B is probability of A plus probability of B minus their intersection. And probability of A given B is probability that they both happen, given that B also has to happen. So find the probability of B if the probability of A is 0.68, probability of their union is 8.7, and probability that they both happen is 3.2. So what's on the left side of the equals sign? The probability of their union is equal to the probability of A plus the probability of B, which is what I'm looking for, minus the probability that they both happen. So 0.87 is equal to the probability of B plus 0.36. So the probability of B must equal 0.51. Nice. Find the probability of the intersection. If the probability of A is that, probability of B is that, and the probability of the union is this. All right, yeah, I got to make sure you have this because it's not on a page. So pause it, write that down. Probability of their intersection is equal to a probability of A plus probability of B minus the intersection. Remember, probability can never be negative, just in case we do the algebra wrong. Sorry, minus. I'm going to subtract 135 from 90. Negative 0.45 is equal to the opposites of the probability of their intersection. So the probability of their intersection is 0.45. Awesome. Let's do 3 and 4. Find the probability of B if the intersection is 0.68. I'm sorry, the given, find probability of B if the probability of A given B, the conditional probability is that, and their intersection is that. Okay, so I know that the probability of A given B is equal to the intersection divided by the probability of B. Okay, I'm going to do a little cross multiplying. 0.68 times probability of B is equal to 0.34. Divide both sides by 0.68. And you get the probability of B, 0.5. All right, got to do a little cross multiplying. And we're going to finish this video out. Same type of question. So probability, here's what you got. That's and. So write that down. So Probability of A given B is equal to their intersection, which I need to find, divided by probability of B. So I just simply cross multiply here. And 1/4 of 28 is 07. Probability of A given B, probability they intersect is low. Folks, that is enough notes for today. Again, your Chapter 10 homework set's due on Wednesday. Again, I sent you that email. Send that in on time. Send that in on time. One of us was late last time. All but one was able to send it in a PDF. Please try to send it in a single PDF. Again, Genius Scan, Cam Scanner, iPhone. Very good. Ask around. Let's try to send that one PDF, and let's be on time. Again, midnight, right? Wednesday at midnight. Again, look on Skyward. I am currently looking on Skyward too. Again, your due date can be midnight. That's fine. Maybe before midnight. I'd like to not get like a ton of notifications at 11 something. So I told calculus, you want to get in the habit of having your homework fully done the day before so that you can just go back and check it again. You want to handle it that way in college, please. Yeah, today's the 26th, and 2 days is 28th. Skyward says on the 28th. So, Wednesday at midnight, you have a lovely Homework Hub video. Homework is pretty short. All right, this is Yak Math Videos signing out.